So hello guys and welcome to my channels. Today again I am back with another important numericals on machine designs. And here we have a numericals. Determine the main dimension, number of radial ventilating duct, number of stator slot and the number of turns per phase of a 3.7 kilowatt 400 volt 3 phase 4 pole 50 Hz squirrel cage induction motor to be started by a star delta starters. And assume the average flux density in the gap is given as here 0.45 Web per meter squares and ampere conductor per meter is 23300 and efficiency is given as 0.85 and power factor as 0.84 and assuming winding factor as 0.955 and stacking factor as 0.9. So here the very first step we'll do for the main dimensions. So for main dimensions here, starting with the solution, first we need to do the kVA input. So in order to calculate the kVA input Q, we have kilowatt upon n cos phi and kilowatt is given as 3.7 kilowatt. Here in the equations you can see 3.7 kilowatt 400 volt is given as 400 volt is given. So kilowatt is 3.7 upon n means efficiency is 0.85 given here. Into power factor 0.84 given, so kVA input will be 5.18 and output coefficient here we have the formula C naught equals to 11 kW into B average into AC into 10 power minus 3. So 11 into kW and in place of kW here we have winding factor 0.955, so 0.955 into B average and the B average is given as here, the average flux density in the gap is given as here 0.45 into 2300 and again the ampere conductor per meter is 23,000. Sorry, here it is 23,000. So you will get here 108.7. Now synchronous speed ns is 2f upon p. So 2 into f is 50 Hz and pole is 4, so you will get 25 rps. And now the product d square l is given as d square l equals to q upon c naught into ns. So 5.18 q we have obtained the value of q and c naught we have also obtained the value of c naught and ns is 25 and here we have ns. So we'll get here d square l as 1.91 into 10 power minus 3 meter cube. Now for a cheap design the value of l by tau will be between 1.5 to 1.2, so taking l upon tau as 1.5 here. So we have L upon tau in place of tau we have pi d upon p, so pi d upon p equals to 1.5, so L upon d, so L upon d is going to give 1.178 here. Now here you can see the relation d square L and here we have the relation as L upon d. So using these two relations we can calculate the value of d as here d as 0.017, so that is equivalent to 0.12 and the value of L will be, and here on substituting the value of d here we will get the value of L from here, so L will be 1.178 into 0.12 will get 0.13 meters. Now pole piece, in order to calculate the pole piece we have tau as pi d upon p, so pi d upon p is going to give 0.094 meters since d is also given in the equations and p is also given in the equations, and here the value of pole piece is 0.094 meters. Now here you can notice one thing, for ventilating duct the stator is provided with radial ventilating duct if the core length exceeds 100 to 125 mm and the width of each duct is about 8 to 10 mm, and here the length of core is here 0.13 meters and therefore one radial duct of 10 mm wide is provided here. So the net iron length alloy will be stacking factor, this is stacking factor into 0.13, here we have 0.13 and a radial duct of 10 mm is provided, so in meter we will get here 0.01, so we will get the net iron length as 0.108 meters here. Now the second we have turn per phase. So first it was main dimensions and in the second we will do for turn per phase. So for turn per phase here you have the flux per pole as 5 equals to b average into l tau and b average equals to 5m into tau into l, we have the formula, and b average is already given in the equation as 0.45 and L and value of L is also given, we have obtained 0.13 and value of tau as 0.094 meters. Here we have also obtained the value of tau and here we have obtained the value of tau as 0.094 meters. So here we have a stator voltage, and here you can see the phi is 5.5 into 10 by minus 3 webers, and as the machine is started by star delta star, it is designed for delta connections. So stator voltage per phase will be 400 volt here. Now a stator turn per phase TS is given as ES upon 4.44 into F phi m into kWs. So ES is 400 upon 4.4 into F is 50 and phi m is 5.5 into 10 to the minus 3 given in the questions. Here phi m is also given in the questions. Similarly kWs is also given in the question as 0.955. So we'll just substitute all the values and get the value of a stator turn per phase as 343 here. Now in the third part, here we have the number of a stator slot. So for a stator slot, taking slot per pole per phase QS as 3, and here we assumed the slot per pole per phase as 3. Similarly, the total numbers of a stator slot will be 3 into a stator slot per pole per phase. So per pole we have per pole 4 pole and per phase 3. So 3 into 4 into 3, that is going to be 36. And a stator slot piece is YSS, so pi d upon SS, so that is going to be pi into d is 0.12 and SS is 36. Here we have obtained the value of SS as 36 here. So we'll get the value as 10.47 mm here, and the number of a stator conductor is 6 TS, so 6 into, and value of obtained, we have obtained the value of TS as 343. So we'll get 2058, and now conductor per slot is given as 2058 upon this SS means 36. So we'll get here 57. And now actual number of turn per phase is given as TS is equals to 36 into 57 into 2 into 3. So here we have used 36 as SS means SS into 36 into, and here we have used ZS as 57, so SS, here we have used SS into ZS upon 2 into, and here we have used the phase. So Z36 into 57 over 2 into 3, and this is going to give 342. And now in order to calculate the winding details, the number of coils will be 36 upon 2. Since we have obtained the value of here we have obtained the number of stator slot as 36. So a number of coil will be 36 upon 2, that is going to be 18, and number of coil per phase will be 18 upon 3, that is going to be 6. So the coil used will be full pitched here. And here similarly, here we have the next one. Find the main dimension of a 15 kilowatt 3 phase 400 volt 50 Hz 2810 RPMs squirrel cage induction motors having an efficiency of 0.88 and a full lead power factor 0.9, and a specific magnetic loading 0.5 Wb per meter square given, and the electric loading AC is given as 25,000 ampere per meters, and take the rotor peripheral speed as approximately 20 meter per second at synchronous speed. And now we have a kVA input as Q is equals to kilowatt A upon N cos phi. We will forward the process same as done in the first numericals. So Q is equals to kilowatt upon N cos phi, and similarly the output coefficient is sine equals to 11 kW B average into 10 to the minus 3, and here all the parameters are given, just we need to substitute all the values. So here the kVA input will be 18.99. Similarly the value of output coefficient C0 will be here 131.3 here, and here the speed of rotor at full speed is 28,810 rpm given in the question, and the nearest synchronous speed corresponding to 50 Hz is 3000 rpm. So we will consider the nearest speed, so it will be 3000 rpm. So synchronous speed ns equal to 3000 upon 60, that is going to give 50 rps. And now the product d square L is given by q naught upon c naught into ns, and here we have obtained q naught as 18.94 and upon c naught, and value of c naught is 131.3 into ns is 50, this value. So we'll get here 2.88 into 10 to the minus 3 meter cube. And now the rotor diameter is an induction motor is almost equal to the stator base. So for that we have a stator bore. So for that we have pi d ns equal to 20. So from here we will get the value of d as 20 upon pi into ns and 50. So 0.1257 meters. Now the value of fuel will be here 2.88 into 10 power minus 3 upon this value. So we'll use this relation to calculate the value of EL. So here the value of L will be 0.177 meters here. So finally we have obtained the value of D and L. So this is our required answer. And again here we have the one more important numerical. Determine the main dimensions, turn per phase, number of slot, conductor cross section area and slot area up to 50 SP, 3 phase, 50 Hz, 400, 1410 RPM, slip ring induction motors and assume. And here B average is given as 0.5 Weber per meter square, value of AC is 30,000 ampere per meter square, efficiency as 0.9, power factor as 0.9 and winding factor as 0.955, current density as 3.5 ampere per mm square. And the slot space factor is 0.4 and the ratio of core length to pole piece is 1.2 given in the questions, and the machine is started the delta connections. So here we have the same process. We have Q as kilowatt upon n cos phi, and kilowatt here we have 250 SP given, so 250 into 0.746 in order to calculate in kilowatt upon 0.9 into 0.9, so you get 230.2. Similarly, output option C naught is calculated 11 kW into B average into AC into 10 to minus A. Just substitute all the values, you will get the value of C naught. Here we have 157.573. So this process is similar to the question number 1. And the product D square L is given as Q upon C naught into NS. And here, before calculating D square L, here first we need to calculate the speed of motor, here NS. So for that, here we have the speed of motor is given as 1410 RPMs and the nearest synchronous speed corresponding to 1410 is 1500 RPMs. So NS will be 1500 upon 60, that is going to give 25 RPS. And now number of pole, and number of pole is also not mentioned in the question. So for that we need to calculate the number of poles. So for that we have 2F upon NS. So 2 into 50 upon NS, and we have obtained NS 25 RPS. So the pole is going to give 4 here. Now D square L. Now D square L we will use this relation Q upon C naught into NS. So on substituting all the values, you will get 0.05843 meter cube. Now L upon tau will be 1.2. This is also given in the questions. Here you can see the ratio of core length to pole piece is given as 1.2. And in place of tau we have pi d upon p, and L upon d we need the relations L upon d. So L upon d is going to give 0.942. And now using these relations and this relation, if you solve this, you will get the value of D and L. So the value of D is 0.395 meters and the value of L is 0.375 meters. Now for turn per phase we have flux per pole phi equal to B average into L tau. So B average into L into tau, and in place of tau we have pi d upon p. Again B average is given 0.5, L is given as 0.375 and tau, for tau we have pi d upon p. So just substitute all the value, will get the value of phi as 0.058 Weber. Now as the machine is started by the star delta study designed for the delta connection, so stator voltage per phase will be ES equal to 400 volt and stator on per phase ES equal to ES upon 4.44 F phi m into kWs. And here ES is given as 400. Similarly phi F phi m kWs is also given in the questions. Just we need to substitute all the values and we will get the value of a stator turn per phase. So the value of TS will be 32.52. Now number of stator slot. So taking slot per pole per phase, here we have assumed the slot per pole per phase as 5. And now number of stator slot ESS. So 5 into 3 into 4, since this is the number of stator slot. Since slot per pole per phase is given as 5 and the number of stator slot will be 5 into 3 into 4, so this is going to give 60. Since this is 3 phase and 4 pole is used, so 3 into 4 that is going to give 60. That is going to give 60. Yes, 5 into 3 into 4 that is going to give 60. Now stator slot, please a stator slot pitch. So for that we have YSS equal to pi d upon SS. So pi into d is 0.395 given, and SS is also 60 here. We have obtained here the value of SS as 60. So 60 0.026 meters, and in mm we have 20.6 mm. Now number of stator conductors is 60 s. So 6 into TS we have obtained the value of TS. Similarly conductor per slot JS will be means 195 upon SS. So SS is 60. So 3.25, and that is equivalent to 3, and this is 60 s, and this is also equivalent to 195 here. Now actual number of turn per phase will be 3 into 60 upon 2 into 3. And here previously we have calculated means SS into, this is the value of ZSS, so ZSS into, and in place of say 60 we have SSS, so ZSS into 6SS upon 2 into phase, so that is going to be 30. Now a stator current per phase IC is 250, SP is given, so 250 into 746 upon 3 into 400 volt is given, and power factor again cable is also given 0.9, so it will be 192 amperes. Now AS will be IS upon del S, so 192 upon del S is given as 3.5, so it will be 55 mm squares. Current density is also given 3.5 mm, ampere per mm square is given, so it will be 55 mm squares. Now total area of slot will be total area per slot upon space factors, so we have total area per slot, for that we have 3 into 55, total area per slot, here we have ES as 55, so for total area per slot will be 3 into 55 upon space factor, so space factor is also given in the questions as 0.4. And here given the slot space factor is given as 0.4 here. So all the parameters are given in the questions, just you need to know how to apply the required parameters at the required conditions. So finally here we will get the total area of slot as 412.5 mm squares. So hope you enjoy the lectures. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.